Okay, final part. Everything is already all factored for me, so that is nice. And for my domain, all real numbers except x cannot equal 2. My wholes, I do not have a common factor in the numerator and the denominator, so there aren't any for me to cancel. My roots, I don't have anything in the numerator to be able to set equal to 0, so there's none of those either. And then my vertical asymptote, I've got x equals 2. Tangency and togetherness, so in the denominator, I have a factor that has an even exponent, which means I have togetherness. Tangency is the numerator, togetherness is the denominator. So my togetherness is at the asymptote where x equals 2. My end behavior, it is it is bottom heavy, which means it is y equals 0 for my horizontal asymptote. And there are no slant asymptotes. Y-intercept, when I set x equal to 0, that's going to give me a negative 2 squared, which is 4, so I end up with 0, 1. Okay, so on my number line, I get to put my roots, which I don't have, my vertical asymptote, which I only have one of, so I'm here at 2. If I use 0, which is on the left-hand side of this, and plug this in, I'm going to get positive over positive, because squaring the numerator, so overall it's positive. On the right-hand side, numerator is always positive. So is the denominator, because I'm squaring it, so it's overall positive here. Now I am going to graph my asymptotes. Or my asymptote, there's only one. Oh, well, no, there's 2. Only one vertical one, though. X equals 2. And then I'm going to do the horizontal one, which is y equals 0. The less asymptotes, usually the less complicated and weird things are. Okay, so then I'm going to go back and plot any points I have. Well, I don't have any roots to plot. I do have a y-intercept. It says 0, 1. And that's like all I got. So I need something on this side. So x, y, plug in. All that stuff is even up there, so I think I'm going to try a 4 instead of a 3. See what happens. So I'm going to have 4 over 4 minus 2 is 2 squared, which is 4, so I'm at 4, 1. So 2, 4, 1. Okay, from negative infinity to 2, it's positive. So I know I'm not crossing down over this asymptote. It stays positive the whole time. All right, so I'm going to come in here like this. And then from 2 to infinity, it's positive. So I feel like it should go like this, which means these would come together. And that is happening because I have this togetherness, right? The togetherness means that we're going in the same direction. So going up to positive infinity here, same thing here, and I'm staying positive, so I know I'm not crossing the horizontal asymptote. And this is what I get. That one wasn't so bad. All right, 26. Okay. Got a factor in here. So when I factor the numerator, this is going to give me x minus 3, x plus 1, all over x minus 2. And then my domain is all real numbers except x cannot equal 2. I do not have common factors to cancel, so there are no missing points here. Roots are at negative 1 and 3. Vertical asymptote, x equals 2. Tangency and togetherness, I do not have a factor that's squared in the numerator or denominator, so that is none. This is top heavy, so since it is top heavy, it does not have a horizontal asymptote, which means I do have a slant asymptote. And I would suggest here, since you have a linear binomial, that you do synthetic division. And you could do long division if you wanted, but this would be my preferred way. I do not need a placeholder, but if you do need one, pay attention and use it. So 1, negative 2, negative 3. don't care about my remainder. This is 1, 2, 0. And that's really all I care about. So what I end up with then is just y equals x. Y-intercept, I prefer to look at this one and cross out my zeros, or my x's there. It's going to be 0, 3/2. So on my number line, I have my roots, which are -1 and 3, and my asymptote, which is 2. So those are the 3 things I need there. And if I plug in a -2, then that's going to give me negative, 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 which is overall negative. I can use 0 here, so it'll be negative, positive, negative, which is positive. 2.5 is going to be negative, positive, positive, which is negative. 4 is going to be positive, positive, positive. So then I'm going to graph my asymptotes. And all I have is a 2. And then slant asymptote, or my oblique one, is just y equals x. Alright, so, alrighty. So I got those in there. Hit that pretty good. And then I'm going to go plot what I can plot. I have a root at -1. I have 1 at 3, 2, 3. My y-intercept is 0, 3/2, so that's 1.5. And I'm right about there. Had no holes that I had to worry about or anything else. Okay, so here's what I know. I know that from -infinity to -1, so all the way out here, all the way to in here, I'm negative the whole time. Is it positive? Is it possible that it could be on the other side of this asymptote? It's possible. We don't know. We're not going to worry about it. We're just going to come up this way. So once I hit this -1, then from -1 to 2, which is where this asymptote is, it's positive. So it's looking like this. Alright, so I had to pause again. So once again, I have no clue what the last thing was that I said. But I do want to throw this in there. Mr. Ackerman came in and we talked about asymptotes for a long time because of, what we had talked about today. But we were also talking about these sign charts. And we're talking about the fact that, I had talked to y'all today about we know that this is going to alternate because of we don't have any tangency or togetherness. And the fact that it's okay to say that and not just assume it, this is still important. But he started telling me about how important this number line thing is in calculus and the concept of it. And that even though, yes, right now we're looking at each one so we can make sure we get it right and get the understanding, that if you know that you don't have any tangency or togetherness, then once you get the first one, it's going to alternate, and you need to be able to do that quicker and not always plug in a bunch of numbers. So even when you start way out here, even though I probably used -2, I don't remember exactly what I said, but we can just think of even using negative infinity out here. So negative infinity, this is going to be negative, 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 right? And so we know that one's negative, then they're going to alternate. And when you have tangency or togetherness, that's when they're going to stay the same. So knowing that also can tell you if you had like a mistake down here. But this is definitely not a trick. This is a tool that you're going to use. This is a tool that we are using to plot our points or to get our graph shape, and it is a tool that you are going to continue to use in calculus, and all this you're going to continue to use, but that number line is something that is definitely a big deal there. Okay, so I'm almost finished with this one. Like I said, I have no idea what the last thing is that I said. So we made this curve. I had this 1 point over here. I do know from 2 to 3 I'm negative, and I did not have togetherness, so I have to start down here. Negative, and then the rest is positive, and so it looks like that. Okay, so that is your last one, I believe. Yeah, this is the last one. And so if you have any questions, let me know, and just make sure that you are ready for the test. I do not have time now because it is almost 5 o'clock, and I still have some other stuff to do before I leave, so I don't have time to go back and talk through 1 through 7. But those got talked about throughout the rest of the the problems and stuff anyway. You're not going to have to like define them out on the test or anything, but you do need to know what they are and how to find them in order to work the test. So make sure you can graph these without freaking out. Take it a step at a time. You can do this. Y'all are pretty good at all the parts. Just make sure that you can factor correctly, and you know what order you're supposed to find things in. All right?